Okay, so in this lecture, I'm going to cover some advanced features of JavaScript, including some fancy stuff you can do with functions and object-oriented JavaScript. Now, in your first piece of coursework, this is going to be very useful because maybe you're going to build, if you want to build a more advanced game with lots of kind of features, like a card game or some kind of advanced Space Invader game, then you'll find these advanced features of JavaScript will enable you to scale your code more easily and organize it better. Now, in the second term, in your e-commerce website, these advanced features are also going to be useful because once you've watched this lecture, you'll then understand the lecture I'm going to give that explains how you can use advanced JavaScript to build a customer recommender and an object-oriented basket. And the third piece of coursework, the single-page web application, will be a sort of very intensive use of JavaScript on the front end as well as the back end. And so obviously if you understand object-oriented JavaScript and the flexibility of functions and so on, that's going to help you with that too. So, you know, before you watch the object-oriented basket or the customer recommender lecture or the node lectures, you should certainly watch this lecture. So the JavaScript so far, it's been very linear in a way. And we're just kind of covering variables, functions, arrays, and objects. And most of your code so far, I'm guessing, has been based on these features of JavaScript. But you can do a lot more with JavaScript. You can do a lot more with functions, and you can also write object-oriented JavaScript that's similar to Java. Don't get too hooked on the idea that it's going to be identical to Java. It's not. It's a little bit different, but it's the same general idea that you can create objects that represent things and then call methods on those objects to change the behavior of the object, to invoke behaviors in the objects and so on. So these features, you know, they're not just sort of fancy stuff that looks cool, right? They also enable you to write code that's more compact, easier to maintain, easier to reuse, and easier to scale up to larger systems. So some people hate object-oriented code and just think, you know, functions, it's the way ahead. But actually, you know, object-oriented programming is, you know, ubiquitous. And there's a reason for that. The reason is you can write better code and cleaner code, and it's easier to maintain. So in this lecture, I'm going to talk about JavaScript functions, just go way beyond, you know, what I've kind of taught so far. Then I'm going to explain object-oriented JavaScript, and then I'm going to talk about prototypes, which are sort of enable you to do inheritance with object-oriented JavaScript. Okie dokie. So flexible functions. So far, for the most part, with JavaScript functions, you've defined the function, and then you've called the function, right? So we've got a function here, say hello, we're passing this argument here, name, and then we can, you know, use this variable, this argument here becomes a variable within the function, and then we can do alert, hello, name, whatever. And then when we want to call the function, we just say, use the function's name, use the smooth braces, and when we specify the argument we want to pass to the function, that Judy is copied into name, and then we can do alert, and it'll say hello, Judy in this case. And we covered variables. So variables, you know, in the JavaScript I've covered so far, can point to, you know, some simple data. So, you know, these are sort of pointing simple like a string, integer, and a Boolean. And they can, and also had a whole lecture describing how you can point it to build more complex objects in JavaScript, right? So here we've got a variable pointing to this JavaScript object within which we have these key value pairs inside the object. So in this case, or there's another object, here's an array here. So again, going back to the earlier lecture on objects and arrays, here we have like an array of things, and the variable here is pointing to this array. Variables can also point to functions, right? So first we assign the function to the variable. So here we have a function. Now we can create anonymous functions. We're going to come to that a little later, but here we're just defining a standard function here, say hello. This function's called say hello. And what I can do, if I want to, is I can point another variable to that function. So here we have just an ordinary variable, because all variables are ordinary variables in a way. They just point us to things. So here we've got a function variable here, and that's pointing to this function here. Now this is where we kind of get the dynamic behind-the-scenes typing of JavaScript. So in this case, JavaScript knows that this is a function type of variable. That's just one type of variable, like you have a string variable, an integer variable, a Boolean variable, and a function variable, right? So because this variable is pointing to a function, behind the scenes, JavaScript knows that that variable is pointing to a function. It's a function type of variable. So now we can actually call the function that this variable is pointing to. So it's pointing to say hello. So to call that function, we just use the same syntax, use the same sort of smooth braces, pass the argument in exactly the same way that we did back here. we just call function variable, which is pointing to the function, put the smooth braces, pass the argument in, and then it'll do exactly the same thing. I think this is the same thing. Oh yeah, so here we have, this is the first example I gave you, right? So here we have the function, defining the function, calling the function, but we can actually define the function anonymously, right? So here we're giving the function a name, say hello, and then, we can call it from anywhere in the code. Here, we're creating the function anonymously. So here we have the variable here, say hello. It's pointing to the function. In this case, that we define it without a name, just says function. That's the arguments of the function. And then inside the curly braces, we have, whatever the function does. And then we can call it in the ordinary way. So rather than having this two-stage process where we have the function and then we point a variable to that function, we can do it all in one line of code here. We're saying say hello, that's the variable. It's pointing to a function, and that becomes the name of the function, and then we can just call that function there. So here we have, hello there, John, when we call say hello with John. And that's exactly what happens when we do build event handlers, right? So you've done event handlers like window on key press, window load, window mouse move, and so on and so forth. And all that's happening here is that when we set up an event handler, we're setting it to point to a function, and then when the event's triggered, that function is called. So here we have a particular function that we want to call when a particular event is triggered, and all that's doing is logging like the char code of the event. And then we're creating, and then we can create a function variable that points to this function, and then we can point our window on key press to that function variable. I mean, obviously we could point this directly, but I'm just trying to make it explicit, what's going on here. So this is basically just pointing to that function there in exactly the same way any variable can point to a function. Right, so we covered JavaScript objects in the previous lecture. So here like a JavaScript object with a bunch of key value pairs, and then we can access the properties of that object using person. So here we have a person object with all of these key value pairs inside it. And if we want to access person name, we do person.name. We want to access the age, person.age, blah, blah, blah. Covered that a lot in a previous lecture. I also mentioned in that previous lecture that we can have functions inside these objects. Since variables can point to functions, we can include these variables inside the objects. So we can also include, so it's no surprise we can include these functions inside objects. And then we have to use the this keyword if we want to access the other properties, the other key value pairs or other variables inside the object, then we have to use the this keyword. So this is a variable key and the value. And so since variables can point to objects, one of these keys can point to a function, right? It's exactly the same idea. If a variable can point to a function, that can be true inside of objects as elsewhere. Now in this case, so here we have our function inside the object. If we want to invoke that function, we just do person and then dot, name of the function, and then the smooth braces to say, call this function, effectively is what those smooth braces are doing. And in this case, this function is inside an object, so if we want to access the other properties of the object, we have to use the this dot notation, because it's saying access the other properties inside this object. Otherwise, if you don't have the this dot in front of name, it will look for a global variable called name. But by having this dot, it's going to find this name that's inside the same object that the function is defined inside. Now, we can store variables in arrays. So it makes perfect sense to think that we can store functions in arrays as well, right? So here we have an array of functions. Not that you're ever likely to use this, but you never know. You may come across it in someone else's code, and then you'll be a bit less confused after seeing this slide. So here you have an array of functions. Again, we're defining all these functions anonymously. We're saying this is a function array, so that's using the square braces here. And this is the first function in the array that does whatever, just logs saying it's the first, second, third function. They don't do much, these functions. So this is an array of functions. Now I can work through this array of functions here, standard way. And to call those functions, firstly, I access, the sort of the index of the function that I want to access here. And then to call the function, I just append the smooth braces. And then here I'm passing in I, because these functions have an argument I, a number argument. So I is being copied into number. And then I can output that here. And then that outputs first function array, second function array, third function array. So I can have arrays of functions, and who knows, maybe that'll be useful. Now we can pass variables into functions, right, as arguments to them. So obviously, since variables can be themselves functions, we can pass functions into functions and invoke them within the same function. All sounds a little confusing. When you play around with it a little bit, it'll start to make a bit of sense. So here we have a standard function here, and then we have another function that I've just called function caller, and this function caller has an argument here. So when I call this function caller, I can pass this function as an argument into this function. So here, when I'm calling this, I'm passing say hello in, and that means that I'm saying this function here is being passed as the argument into this function. And now, again, this is JavaScript's dynamic typing, so it knows that this, behind the scenes, it knows that arg, in this case, is a function. So when I append smooth braces to it and give it an argument, then it will call say hello and pass David into, copy David into this here. So this is a three-stage process. So I've got a function caller, I'm passing a function into here, and I can call that function within this function here because I'm passing it into it. And we can also return functions and functions, right? So here we have a function that creates a function. So what the function does is it defines a function called say hello in this case here, which says alert or whatever, and then it can return that function from that function. So it's within that function, it's creating another function and returning it. So here we can have a new function. So we can call this create function function. This will return the say hello function, and then now this new function will be pointing to the function that's returned from this function. And then once I've created this function, I can then call it, and so I can do new function amber, which will say, say hello, will do alert hello amber. So, it does mess with your head a bit, but makes some kind of sense as well. Once you get that function, that variables can be strings, booleans, whatever, arrays, objects, whatever, and functions, that function is just a type of variable, then this makes perfect sense. So since functions are just like variables, we can compare them. When you're comparing functions, the triple equals thing returns true if both variables are pointing to the same function. So I hope you can read this, but the basic idea is here we've got these say hello 1 and say hello 2 are actually doing identical things. There's no difference between them functionally, but they are separately defined functions. And then we've got say goodbye, which does something a little bit differently. So in this case, and I've also got a hello pointer, which is pointing to say hello 1. So hello pointer is an identical function, like they're both pointing to the same data structure in memory, if you like. So in this case, we've got, we're comparing say hello 1 and say hello 2. Well, they're different functions, so that's always going to return false when we compare say hello 1 and say hello 2, because it only returns true, this comparison operator, when it's exactly the same function. So obviously say hello 1 and say goodbye, they're different functionality and different functions, so they're going to be returned false. But if we compare say hello 1 to the hello pointer, since they're both pointing to the same function, in this case say hello 1, then it's going to return true. They're both pointing to the same function. Now when you're writing your code with some way, when you declare functions in the ordinary way, you don't have to worry about the order in which you're writing things, because the browser's making two passes through the JavaScript. So the first pass that the browser makes through the JavaScript is looking for explicitly defined functions. So the browser will do a quick whip through all the JavaScript. I imagine Node does the same, and it'll look for things that are defined in this kind of way, right? It's got a function, saying it's a function, it's giving a name to that function, and then it's got some code that will be executed when that function's called. So it'll look for all these explicitly defined functions, and then the second pass, it'll actually execute the code. So in this case, when you have an explicitly defined function, I can actually call that anywhere inside the code. So in this case, I've got a function here. Although that function comes after, I'm trying to call the function here, and then the function is defined after that. That will work fine, because the browser will have done one pass through, it'll found that function, so I can then call it before the function's actually written in the code. That'll work. But if you've got all this kind of weird stuff with functions being created within functions or anonymous functions, anything like that, then you won't be able to call them until they've actually been explicitly created. So this bit of code here will not be executed when the browser makes a first pass through the code. So it can only be called after it's been created. So in this case, we're creating a function anonymously, right, and assigning it to the variable here, called myFunction. So that's defined in a sort of, it's not defined in the sort of standard way here. It's defined, we're creating that function dynamically. The browser will actually have to execute this piece of code in order to be able to execute this function. So it's not going to do that in the first pass. All it does is look for explicitly defined functions. So this will not work. I can't call this until this piece of code has been executed. So this actually has to come after here, because this creates the function, and then this executes the function here. So this will work. This will not work, because the browser only looks for this kind of way of defining functions in its first pass through the code. Okay, so just trying to bend your minds a little, with all this kind of function stuff. Sometimes that'll be useful, sometimes it won't. The most compelling reason for all this weird stuff with functions is because other people will use that because they sort of, it entertains them, or they're really into it, whatever. And so at some point you're going to come across code that looks really strange, and some of the reason that it looks strange is because they're using these advanced features of functions in JavaScript. And maybe you'll find that useful in your own code as well at some point. However, so the function stuff is of marginal utility, I'd say, in your projects, but this object-oriented JavaScript is going to be much more useful in it. So as I mentioned in the beginning, some people find object-oriented programming difficult to grasp. It's like, these objects and methods and creating objects, constructors, and blah. Yeah, there is a bit of stuff to learn. I'm not denying that at all. But I personally find it much, much easier to work with, because I sort of think of things when I'm trying to model the world, or I'm trying to build a computer game or something. I think very much in terms of objects, and then it just is this whole sort of encapsulation thing, that you can kind of wrap up one bunch of functionality and associate that with some kind of concrete object. Like if I'm building a Space Invaders game, one of the objects is a spaceship, then some of the other objects like meteorites, and the spaceship and the meteorites are going to have like different behavior, and then I might have bullets, and the bullets themselves will have different properties and behavior. And so by having objects, you can kind of wrap up this functionality for the spaceship, the meteorites, and the bullets, and allow them to interact with each other. And that's much, much easier, I think, than kind of calling functions that kind of change globally defined variables that represent different aspects of your spaceship and your scene, and so on and so forth. So you can break problems down much more easily, and you can also do what's called encapsulation. So, if you don't have objects, you're going to have an awful lot of global variables drifting around, and that's going to get complicated when you include lots of different files in which all these different global variables are defined, and you're going to end up with a total mess. You're going to pollute your global namespace, I think is the correct term for that. Whereas if you have objects, then a lot of the variables can all be stuck inside the objects, and then they're not going to sort of collide with each other in unpleasant ways. It's going to be a lot less buggy code if you can wrap up a lot of the variables inside the objects. So the general idea is that you can create objects that correspond to objects in the real world. You can have behaviors to these objects that correspond to the behaviors of objects in the real world. And believe me, it will simplify your programming. It won't simplify your programming if you only got 100 lines of code. When you got like 10,000 lines of code, believe me, it'll simplify it. Now, you don't have to use objects in your life. I believe the Linux kernel is still written without objects, and that's pretty complicated, right? But in general, it's going to simplify your life and make everything beautiful, wonderful, and easy. You can write much more complicated code in this way, particularly when you come to your third-year projects. So I'm going to explain how you can do that in JavaScript now. And when you come to your third sort of web application, believe me, your objects are going to be pretty handy. So I've explained how you can add functions to objects, right? So this is a function inside an object, so it's almost object-oriented already, right? We can invoke methods, do persons.sayHello, and this function can access different properties inside the same object. So this looks a lot like a Java object already, right? It's got the the variables and the methods here. So yeah, in this case, we've got the method inside the object. But in this case, if we're defining objects like this, each object's created individually, right? I have to laboriously, if I want to create a Susan object, then I have to write out the Susan object that has the sort of method here, say hello. If I want to create a Bob object, then I've got to create another object. So there's a lot of duplication of code, and maybe if I get the name slightly wrong here, then I won't be able to invoke the same, or the name slightly wrong here, I won't be able to invoke the same method on Bob object as the Susan object. It's going to take a lot of typing and be a lot of wasted typing because these two bits of code are almost identical. So you're going to get mistakes, and it's not going to save you much time if you create objects in this way. So what we want to do is, what we have in all object-oriented languages, is that we want to be able to use object constructors. An object constructor you can think of as like a factory that will basically churn out identical copies of the same object. And so to make object constructors work, yeah, you can use the keyword new, behaves like a factory, creates a new object. By convention, the constructors of objects start with a capital letter, but make sure you use new or it won't work. So I'll give you a little example, probably make it much easier. So instead of having, so I think we go through all these differerences a little bit, but I'll go through, just go through a quick example, just give you the feel for it. So here, instead of having, in this case, we're just defining our object with a kind of squiggly braces or whatever. This is a variable here. But in the case of a constructor, it's actually a function. And the function has a couple of arguments, in this case, name and age. And what the function does, it says this.name equals name, this.age equals age. Obviously, these could have different names, right? And then we can create a function here, this.sayHello. So it's saying this, using the this keyword, to assign the kind of properties to the objects in a dynamic way. So here we can have Bob equals new person, pass in a couple of arguments here, and then we create Susan equals new person. That's going to build a person object that has a name property and a name age property and a say hello function inside of it. So that when we've created these new person objects, the Susan and Bob, we can then do bob.sayHello and susan.sayHello. So in this case, we've only got one piece of code that creates the objects, and then we're creating identical copies of the same objects. The same object I gave in the previous example, but just created dynamically using this constructor. So here we've got hello, I am Bob, and hello, I am Susan. So I'm going to go through this in a little bit of detail. So this is the difference between them. So here we're creating an object in this kind of way with the curly braces, the sort of method I've taught in the previous lecture, and here we're using the function here. I'm going to go through the differences. So first difference is, when we're creating variables, we typically give variable names. Variable names typically start with a small letter, okay, whereas constructors typically start with a capital letter. It's a convention, but if you stick to the convention, that's going to make your code easier to understand when you go back to look at it a little bit later, and it's going to help other people to understand it as well. Now, in this case, we're saying variable var person defining a variable and assigning, and that variable is an object type because we're creating an object here. In this case, it's a function, and so in this case, we have a sort of, this is the name of a function, this is the name of the variable. Of course, variable can be a function type, blah, 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 but this is a function. And then the function has a couple of arguments here, which are used to customize the objects that we're creating. You don't have to have arguments, but if you want to customize the object, then that's what you want to do. And here we just got name, age, and say hello, which are the properties of the object here. In this case, we're creating an object, and we're saying that in this case, the object that we're creating will have the property name, age, and the function say hello. So we have to use the this dot to assign the, otherwise, if we don't have the this dot notation, it's just going to create a globally defined object, global variable with name equal to name. But by using this dot, it will create an object, and the function will return an object with the property name, age, and say hello. And finally, when we're creating a variable, we end with a semicolon because it's like a line of code, whereas functions aren't lines of code. You have to call them elsewhere, right? So we don't end that with a semicolon. And yeah, as I said, we can then create two objects very easily and quickly, and pass in particular properties that we want to be assigned to the properties of the objects. So then we can create two objects just like that, whereas we'd have to duplicate that piece of code twice to create two objects in this case. So it's much quicker and easier to create objects in this way. So once we've created an object, that object is just an ordinary JavaScript object, and then we can modify anything we like inside it in just the same way we can do with any JavaScript object. But when we change an object that's been created with a constructor, we only change that individual object. We don't touch any of the other objects that have been subsequently or previously created with that same constructor. So here we've got our constructor. We're creating a new person Bob, new person Susan. But what I'm going to do is I'm going to say, after I've created my Bob object, I'm going to change the say hello function to say, in this case, greetings, I am, whatever name is, whereas this is saying, hello, I am. So after I've created the Bob object, I'm going to change it, change the say hello function. So now when I say hello with Bob, it says, greetings, I am Bob. But when I do Susan.sayHello, it just says, hello, I am Susan. So I've only changed the Bob object. I haven't touched the Susan object, because both objects are, once a constructor creates an object, that object just goes off into the world and does its own thing, and there's no longer any connection between the constructor and the object, or between the objects that are created with the same constructor. Now, once you've built an object with a constructor, it becomes an instance of a class, and the class in this case is the name of the function that's used to create it. So we want to find out, what class an object is, which might be useful sometimes if you're doing really complex code. Then, for example, here we got Susan created with a person class, and this is checking to see if Susan is an instance of the person class. So person is the name of the function that's the constructor function. So in this case, this will return true because Susan was created with the person constructor. Right, so that's the basic object-oriented JavaScript stuff, and really the only difference with this sort of adding methods and variables manually to objects is the fact that you can use a constructor to build the objects dynamically, which is a very handy feature. But, if you want to create 100 trees, right, with different properties, you're not going to write all that out manually. You're going to use a constructor, right? Okay, now finally I want to talk about prototypes. So prototypes are the sort of most advanced object-oriented features in JavaScript, and in many cases it'll make sense to use this stuff. So as I mentioned before, the problem with constructors is advantage, maybe depends what you're trying to do, but generally generally a limitation is that the objects that are created with a constructor are completely independent. You basically it's a factory, it churns out the objects, and the objects go off into the world, and there's no longer any connection between them. So you get two separate copies of all the functions and variables, so it's not very memory efficient, but not such a big deal these days. More importantly, there's no possibility of inheritance with standard object construction. So if you want full object-oriented programming, you need to use prototypes in JavaScript. And it's very important not to confuse the prototype language feature, which is an inherent property of JavaScript on all modern browsers, there's this kind of prototype JavaScript library. Very stupid, confusing name, right? Calling it, after a language feature, but no idea what the connection is there. But don't mix up the prototype JavaScript library with the prototype language feature within JavaScript. Okay, I'm only talking about features of the language, just like variables are a feature of the language. Yeah. Now, when you're thinking about prototypes, they can get a bit confusing. I won't deny it, but it might reduce that confusion if you think about what the meaning of the word prototype is. Okay. So prototype is kind of defined as the original or model on which something is based. So it's like, it can also mean like if you're designing a new product, you might have a prototype, in which if you're building a prototype of a product, it's more like a rough sketch. And that kind of also corresponds to the meaning to some extent. But it's more better, I think, to think of it as a sort of a definition or original model, and then everything is kind of based on this original pattern, if you like. If you change the prototype, you kind of change the objects based on the prototype. So might help, might not, but hopefully it'll be a bit clearer when I've gone through some examples. So as I said, when you call a function with a keyword new, it's behaving like a factory, like a rubber duck factory, right? You churn out all these identical rubber ducks, and if you chop the head off one of the rubber ducks, all the other rubber ducks don't lose their heads, right? The factory's produced 100 rubber ducks. I chop the head off one rubber duck, and the other 99 rubber ducks remain, fully headed, right? So we've got the constructor here. We use the new, and we use new person, and then that creates a new object of this with a name and the age, returns it, and assigns it to the variable Liz in this case. So the new object is an instance of the type of object that the function creates. So Liz is an instance of the person object. Now, each function also has a prototype property, and that defines the type of object that's created with the new keyword. And this prototype property enables other objects to inherit properties and behavior from other objects. So we need to use prototypes if we want to make inheritance work, and it creates a tight linkage between all of the objects that are created with the same constructor, as I'll explain. So okay, so here we have a function person. In this case, we're passing in name and age and assigning the name and age to the person. Now we have Liz, a new person here, creating two objects, Liz and Sam, So these will just be kind of person objects, right? Exactly the same way I've covered already. Now what I can do is I can add a new property, height, to the prototype of this constructor here. So by doing person.prototype, I'm controlling the kinds of objects that are created with the constructor. And most importantly, I can do that after the objects have been created. So here we've got the prototype constructor. I'm creating two objects, and I'm modifying the type of object that's built with this constructor. So in this case, although Liz and Sam were created before I changed the prototype property, they still have this height property here. So in this case, height, I've said that the height property is 2. So after the objects have been created, I'm adding a property to the prototype, and that property immediately appears in all of the objects that have been created with that particular constructor. So going back to the rubber duck analogy, right, I've got a factory that churns out 100 rubber ducks, and let's say the rubber ducks, it's a bit strange to think about, but in this case I'm changing the factory such that I'm telling the factory, well, let's add a hat to the duck, right? Let's add a hat to all of the ducks created with this factory. So the factory has churned out 100 ducks. I'm modifying the factory by saying let's have the hat property, and then suddenly all the ducks that have already been built, suddenly, magically they all get hats, right? That's the idea here. So by changing the factory, I'm actually changing the objects that have been built by that factory, even though it's a retrospective change. And we can add functions to a prototype. So in this case, we've got a standard constructor just with a name and the age property. I can add to the prototype another function. In this case, it's like a say hello function. And I can add like adding a university property here. So when I do Tony say hello, so the property here is like, hello, I am this, outputs the name and outputs the university. I'm adding the university property here. So when I call the code, creating an object here. So this Tony will have both a university property because I've added it to the prototype, and it will have a say hello function as well. So when I call Tony say hello, I'm calling this.university, that works fine because I've got a university property added here. So it's like, hello, I am Tony, I study at Middlesex. So objects created with a standard constructor are completely independent of each other. So I said with a standard constructor, your 100 rubber ducks, out they go at the factory, and then if I add the hat property to the ducks, to the duck factory, then the subsequent ducks that come out of the factory will have a hat, but the first 100 ducks that came out of the factory will not have a hat. Okay? If I change the prototype property, then that modifies all of the objects that have ever been created with that factory so that they all will suddenly magically have hats. So in a prototype, there's only a single copy. Oh yeah, so that's this point about independence. And the reason that they are not independent when you're starting to use prototypes is that there's initially only a single copy of all the functions and variables with the prototype. That's why all the ducks kind of gain hats, because they're in a way sharing the same hat. Okay, so it's a slightly peculiar metaphor, but whatever. So if we add a method or variable to the prototype, it immediately becomes available to all of the objects that are based on the prototype. So you can easily change the behavior of all objects of a particular class. And that enables prototypes to support inheritance. So the inheritance works because we can base the prototype for an object on another prototype. So an object can inherit functions and properties from another object. So here's a little example. So here we have our person object. So we're creating a person, which has a name and an age. And then we have a function, the constructor, for a student. In this case, just adding like a university property to the student. Now here's the sort of crucial bit of code here. We're saying that student, the prototype of a student, is actually pointing not, in this case, we're not adding properties here. That would be adding properties at the end of the prototype. We're saying that the prototype itself is a person object. So when we create a new student using the constructor, we're passing in Middlesex here to the constructor, which will store Middlesex here. But it's also going to inherit all of the properties from person, because I've said that the prototype starts off being like a person object. And then when I do a new student.name, it'll say John 21 or whatever, and new student.age, John 21, sorry. And I'm also going to get the university property that I've also added to the prototype. Have I added it to the prototype? Yeah, I've added it in the constructor here. So in this case, we're gaining the name and age properties because we've said that the prototype we pointed the prototype to this person object here. And we can also do this in a sort of in a better way. If we instead of, in this case, I'm pointing the prototype to a standard object here. But if I point it to a constructor, in this case I'm pointing it to the constructor itself, not to an object, but to the constructor that's used to build an object. And then I can use this constructor to initialize my person object as well, and then call the initialization of the other data that I want to. So when I do new student, I can pass in a name, age, and the university. So this calls this with the name, age, and the university. And then within this constructor function, it will then call, I can then call person, because the constructor for a person, inside the constructor for a student, I do person.call, that's the syntax for this. I'm passing in a reference to the object I'm creating, and I'm also passing in the name and the age here. So in this case, this.name, this.age, I can then initialize my entire object, both the object I'm inheriting from and the student which inherits from the person. And then we get John, 21, Middlesex. So this is, this is probably as sophisticated as it gets, at least as far as I'm aware, and sometimes this will be useful. So just sort of file it at the back of your mind, and if you're building lots of complex stuff and you find inheritance to be a useful way of writing your code, then it'd be very useful to be able to initialize both the object that you're inheriting from and the object itself. Yeah? So in this case, we're initializing the parameters or variables or whatever of the student and the person, which you can't do if you're doing it in this other way, because when we're basing it on an ordinary object, we've got no way of setting up. These are just set up. This will always be John and 21 because we're not initializing it in any way. But if we're doing this person call stuff, we can then specify the name and the age of the person that we want to build as our student. Now, initially, when you add stuff to the prototype, all of the objects created with the prototype share those variables and methods. But you can override the methods and variables in the prototype. You're not bound to them forever. All the ducks don't have to wear the same hat, right? So first, the browser will check the objects that are being created for a particular method or property. If it can't find that in the object, it will look inside the prototype that the object was based on, okay? And this prototype might be based on another prototype, and you can get into some kind of mind-mangling kind of, chains of inheritance, but we're not going to go there. So in this case, we've got a person constructor, and we're saying that and then we're adding a function to the prototype. This has got like a say hello function, which just says, hello, I'm this name, this university, or whatever. And I'm adding a university property to the prototype as well. So prototype has a say hello, has a university property, and when we can create something with that, then it'll also have a name and an age. So here we're creating a Tony, new person, blah, 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 Susan, new person, blah, blah, blah. But what I'm doing here is I'm actually changing the say hello function inside Tony. So initially, Tony and Susan would share the same function here because it's the prototype function, but then I'm overriding it here. I'm saying within Tony object, I want it to have a different function. I want to say this is a modified say hello function. So when I do Susan say hello, it's just the standard function within the prototype. But with Tony, because I've modified it, it's saying, hello, this is a modified say hello function. So you're not constrained to have all your objects linked to the single function. You can actually dynamically change and modify the functions if you want to. So it's useful sometimes to have them all share a function, but sometimes it's useful to do something different. So this is only a little bit of a sketch, but I hope it's given you enough to understand, well, the object-oriented basket and the customer tracker recommendation. And also, when you're looking at other people's code, you'll often find object-oriented JavaScript and prototypes being used, and so I hope that's given you enough of a handle to understand it. But this is only like a 40-minute lecture or whatever. If you really want to understand this stuff, I recommend you work your way through the Head First JavaScript programming book. Chapters 5 and chapters 11 and 13 go into this in a lot more detail, and they've got some exercises you can work through because you're never really going to understand this until you try out some code and make it work for yourself. So this lecture has been all about the advanced features of JavaScript, and the next lecture is going to go into the second piece of coursework, the e-commerce website.